Okay, everyone. I'm Cayden. This is Brianna, who's recording. Say hi, Brianna.
Hi.
And today I'm going to talk to you about paramagnetic levitation. It's really, really cool. It's a lot different than what we normally think about when we think of magnets. So to kind of explain what this is and how to levitate random objects, we're first going to talk about different kinds of magnets. So up here, we kind of have three different kinds of magnets. We're excluding electric ones, but they're ferromagnets, and those are kind of what we view as our normal magnets. So what you normally think of like iron is a ferromagnet. So something with inherent magnetic abilities with poles. But there are also two other different kinds of magnets that are a little bit different. They're paramagnets and diamagnets. Paramagnets are attracted to magnets, while diamagnets are repelled. And we'll talk about what differs between those, but pretty much any material fits into one of these categories. So it's really, really interesting. And we can kind of use that to do some fun things. One easy way to remember, I'll explain that in a minute, but diamagnets would rather die than be next to a magnet. So diamagnets are repelled. You can kind of see that over here with these field lines. So for ferromagnets, like iron, the field lines like to go through them. They kind of squeeze through the object. Paramagnets, it kind of just goes straight through. And then diamagnets, they really don't like them. They kind of get pushed around the object. So they get pushed by field lines. Yeah, so it's really, really cool. The reason why materials are either paramagnetic or diamagnetic, it depends on their molecular structure. So if you come over here, this is just an example of a atom. It's not correct, but it's just a fake one. But there's a nucleus of every atom, and then they have electrons that fly around. But electrons like to fill up shells first. So there's kind of an order to how they attach to an atom. So there's a first shell and a second shell, and they like attaching in pairs. And so they'll first fill up this first shell with 2, and the next one will get filled up with 6. This first shell is the S shell, and the second shell is the P shell. And there's multiple shells after that. But if you look into it, an object like aluminum, it has 2 S electrons and only 1 P. And so because this electron doesn't have a pair, it's just kind of flying alone. And aluminum then is a strong paramagnet. So it really likes magnets. But if we change this to be argon, Brianna's good at chemistry, she knows. Argon actually fills up all of these. So argon does not have any unpaired electrons. And so argon is actually very diamagnetic. It's repelled by magnets. And so paramagnets have unpaired electrons, and diamagnetic elements would rather die than be with a magnet. So I hope that cleared up some things. It's really, really cool. So by using this, we can kind of mess with random objects. It's really cool because it still follows the same rules as normal magnets. They follow Lenz's law. So electromotive force, so like how hard it's pushed or pulled, equals the negative change in flux over change in time. And flux is the magnetic field times the area of the object you're trying to levitate. But levitation has some other variables in it. So this is kind of the equation they would use. So it looks pretty complicated, but we'll explain it. But the magnetic field, B, is multiplied by the rate of change of B vertically. So that's the derivative there. Equals U naught is permeability. That's kind of like how easily it's moved through air. I mean, if you did it in water, that would change, but that's the permeability. Density, P, of the object, and then that's multiplied by the gravity of free space over chi, which is magnetic susceptibility. Which, going back up here, that relates to what element is used. And so using this, we can have a lot of fun. They do really funny things. So some people have made magnets that levitate a globe. And so you can have a 3D floating globe in your room. Or some scientists had some fun and they floated a frog and some other things in this big container. Usually they use diamagnetic levitation. Paramagnetic levitation isn't really used, but it's easier to push the things. So it's really, really cool. Really, you can levitate anything, even a human, using the water in us, but it would take so much magnetic field strength that's pretty difficult to do. So that has not been done yet, but I'm sure sometime you'll have floating people going around. Maybe we could use it for transportation. That'd be really cool. But anyways, thanks for watching. Like and subscribe. Thanks.